All right, welcome back. So in this video, we're going to start thinking through all of the different ways that we can allocate two goods among two individuals in what we'll call an endowment economy, which, as I said, right, is an economy where we're not producing anything, we just have a certain amount of stuff and we're deciding who gets what. So let's think about a specific example. Let's imagine that you're sick of this year of plagues and fires and chaos and disaster everywhere. So you decide that your best bet for your future, your best hope for a good life, is going to be to try to get yourself abducted by aliens. So you cash out your life savings, you fill up a van with all of the beefaroni and water that you can carry, and you drive out to the New Mexico desert, right, to your favorite crop circle location. So let's imagine that you've got let's say 700 cans of beefaroni, and let's say you've got 50 gallons of water. Right? You get out to your crop circle, right? You're ready to hunker down, and you notice that there's already someone there. There's this grizzled old survivalist who's been out there since Y2K named Maud, and Maud's got, let's say, 450 gallons of water, but she's down to only 300 cans of beefaroni. So we'll say beefaroni for Maud is going to equal 300, and the water for Maud is going to equal 450. Cool. So what this means, right, is that all told, in our economy, we're going to have, right, 700 plus 300, 1,000 cans of beefaroni, right, and we'll have 500 gallons of water. So if we want to understand all the different ways that we could potentially allocate beefaroni and water between you and Maud, right, we can graph all of the possible combinations of beefaroni and water that you could consume by making a graph, right, that looks like our budget constraint or indifference curve graph with, say, beefaroni on the vertical axis, water on the horizontal axis, right? Where we can have anywhere from 0 to 1,000 cans of beefaroni, and anywhere from 0 to 500 gallons of water, right? We're just saying, right, on this graph, we can basically represent any possible outcome of your interaction with Maud, right? Anywhere from you having nothing to you having everything that exists in the entire world. And we can say that if nothing happens, right, if you just keep what you started with, you would have 50 gallons of water and something like 700 cans of beefaroni. So we would start out here. Cool, okay. So we've gotten started thinking about your problem, right? We're saying these are all the possibilities for you. But what if I wanted to graph all of the possibilities for Maud? Right, in other words, what if I wanted to know not just how much you have, but how much you have and how much Maud has? Well, what I can do, right, is I can say that whatever you don't have is what Maud has, right? Whatever you have, Maud doesn't have. In other words, if I know that you have 700 cans of beefaroni, I know that Maud must only have 300 cans of beefaroni, right? If you have 50 gallons of water, Maud must have 450 gallons of water. So I can show this graphically by drawing a new set of axes for Maud. It's just an upside-down version of the axes that I drew for you, right? So I can put beefaroni for Maud here, right? This is your beefaroni. I can put water for Maud here, where this is your water, right? I can say that if you had 700, right? If you had 1,000 cans of beefaroni, Maud would have none. If you had 500 gallons of water, Maud would have none. If you had 700 cans of beefaroni, Maud would have 300, right? If you had 50 gallons of water, Maud must have 450 gallons, right? So what we're doing is we're showing graphically whatever you've got, Maud doesn't got, right? And vice versa. Whatever Maud's got, you don't have. Cool. We're going to call this thing, right, this box that represents all of the possible outcomes of our endowment economy, an Edgeworth box. It's called a box for obvious reasons, right, because it's shaped like a box. We call it an Edgeworth box because it was first devised by an economist named Francis Isidro Edgeworth to try to think through problems exactly like this one. Okay, so far so good, right? We've graphed all the possibilities, but now we want to be able to say something about which of these possibilities are better than others. So what if to start with, I wanted to say, out of all these combinations of beefaroni and water, which ones do you like better than your initial endowment, right? Which ones do you like better than having 700 cans of beefaroni and 50 gallons of water? So how I can separate, right, better from worse for a particular person is I can draw an indifference curve, right? So I can say which of these outcomes is better for you, which ones are worse, is going to be whichever ones are above or below your initial indifference curves. So this is going to be the indifference curve for you. Cool, right? So I can say everything up here is better than your initial endowment, everything down here is worse than your initial endowment. Well, what if I wanted to do the same thing for Maud, right? I want to know for Maud, what's better and what's worse than her initial endowment? Well, I can do the same thing, right? I can draw her indifference curve. The only trick here is going to be, we've got to remember that from Maud's perspective, this way is up, right? This way is towards more stuff. From your perspective, right, you're happier with more stuff. For you, she's happier with less stuff for you because that means more stuff for Maud. So her indifference curves, right, are going to look something like this. Yeah, so this is going to be the indifference curve for Maud. Cool. Again, through her initial endowment, right? So we can say everything over here is better for Maud than having 450 gallons of water and 300 cans of beefaroni. Everything over there is worse for her than having 450 gallons of water and 300 cans of beefaroni. Right? And the reason that I drew this curve bending the opposite direction of yours is because we're going to think that diversity is better for Maud as well as for you. Right? In other words, if I draw some line between any two things on Maud's indifference curve, right, the average is going to be better for Maud than the extremes, right? So this is Maud's indifference curve. Her preferences are going this way. She's happier in this direction. Your preferences are going this way, right? You're happier in that direction. Cool. So if we look at this graph, right, we'll look at this graph of everything better for you than the initial endowment, everything better for Maud than the initial endowment. I want you to think about whether it's possible that you and Maud could be made better off by coming to some agreement than you would be if you just kept to yourselves. In other words, if no one's allowed to, be violent to anyone, you can't steal any of Maud's stuff, she can't steal any of your stuff, right? Is there any way for you guys to trade and both be better off? So I'm going to argue that the answer is yes, right? And the reason that the answer is yes is because if we take a look at all the stuff that's better for you than the initial endowment, right? All this stuff over here is better for you. I'm sorry, this is better for Maud. Lost track of what I was doing there. Right, all the stuff that's better for Maud than the initial endowment. And then we look at all the stuff that's better for you than the initial endowment. There's this area here that's better for both of you. Right? So if you guys are at all capable of negotiating, you should be able to settle on some option somewhere in this area, right? In the direction of you getting some more water and giving up some beefaroni, right? Her giving up some water and getting some beefaroni, that makes both of you happier. We're going to call this area here, it's better for both of you, the negotiation space. Because if you guys are negotiating, right, you're trying to come to some agreement, your agreement's going to have to end up somewhere in here, right, somewhere that's mutually beneficial. Okay, so if the two of you trade, right, if you're capable at all of coming to some agreement, it'll be somewhere inside this negotiation space, right, somewhere that's at least as good for each of you as your initial choice. So let's imagine, right, Maud made you an offer like this one. Right, you grudgingly accept, because even though you're no better off here than you were in your original choice, you're no worse off either, right? So you don't see any particular reason to refuse. Are we done negotiating here? No, right? We still have a negotiation space. There's still some possibility that you would be better off and Maud would be better off than if you were at this point here. we're only going to be done negotiating. We're only going to have to say that there's no more point in continuing to trade with mod, right? If there's no overlap between your indifference curve and hers. In other words, if there's no point that's above both your indifference curve and her indifference curve, which is going to happen when your indifference curves touch at just one point. In other words, when we have a picture that looks like this. Right, so at this point here, we can say that there's no more room to negotiate, right? Because there's no overlap between things that you would prefer and things that mod would prefer. There's plenty of stuff you would prefer to this point, right? You'd prefer to be here. And there's plenty of stuff mod would prefer to that point, right? She would rather be there. But there's nothing that you guys are going to agree upon as being mutually better than this point. So we'll call this sort of allocation Pareto Optimum. And what this means is that there's no other allocation that's better for everyone, right? That's better for both you and for mod. In other words, right, we can say that we're at a Pareto optimal allocation when you can't make anyone better off without making somebody else worse off. Another way of thinking about this, right, if this is helpful, is that we know we're at a Pareto optimum if we thought about trying to maximize our own utility, treating mod's utility, mod's indifference curve as our budget constraint, right? So we said as long as mod is going to be as happy as she is here, what's the absolute happiest we could be? It would be this point right here, right? We would be happier here than we would be at any other point on mod's indifference curve. Cool, right? So this is the idea of Pareto optimality. Now, I have a question for you. I want you to think about something. Is this the only point that's Pareto optimal? Is this the only choice where we couldn't make you any better off without making mod any worse off? So the answer to this, right, is not really. It's the only choice where you could be no better off when mod's exactly as happy as she is here. But a point like this is also Pareto optimal. Right? This is Pareto optimal as well. Because at this point, you're a little happier than you were there, and mod's a little sadder than she was there. But at this point, you can't be any happier without making mod sadder. Right? There's no overlap between your indifference curve through this point and her indifference curve through this point. And likewise, right? Some choice like this is Pareto optimal. Right here. Right? You're sadder here than you were there, but mod's happier, right? And mod can't be made any happier at this point without making you even sadder. And likewise, you couldn't be any happier at this point without making mod any sadder, right? There's no overlap between your indifference curves there either. But even here, right, we're not done. If we're just asking about what are all of the options that where one person couldn't be any better off without making another person worse off, well, what about this alternative, right? What about mod getting everything and you getting nothing? What if we imagine that, mod pulls out a sawed-off shotgun and threatens to take all your stuff and leaves you alone to die in the desert? Well, if that happens, right, mod's indifference curve through that point will look like that, right? She's happy as a clam. She couldn't be any happier, right? You're totally miserable, right? You've got nothing. You have an indifference curve like that here, right? But the fact that you're extremely sad doesn't change the fact that mod can't be any happier without making you sad, right? So this is also a Pareto optimal point, right? This, and this are all Pareto optimal. And same with the option where you get everything and mod gets nothing, right? If we consider this is also Pareto optimal. In fact, we can say that at anything between you getting nothing and you getting everything, there's going to be some Pareto optimal allocation, basically charting a path all the way through these alternatives, right? So there's going to be some set of choices like this, right? Each of which is going to be Pareto optimal, right? With different levels of satisfaction for the two individuals involved. So at each of these points, right, we can draw an indifference curve for you, we can draw an indifference curve for Maud, and they're going to touch just one point. That's going to make each of these choices Pareto optimal. And we'll call this path basically from your utter misery to Maud's utter misery, our contract curve. Essentially because if you and Maud are both good negotiators, right, you're capable of noticing when there's an opportunity for mutual gain and taking it. Any contract you write between the two of you is going to have to end up somewhere on this line, right? Any point off this line has some alternative that's mutually preferred by both of you. So essentially what the contract curve is, right, is the set of all possible Pareto optima. And the one last thing that I want you to think about, one last feature of this graph, is if you and Maud are negotiating, right, neither of you are pulling a sawed-off shotgun on the other, right, so you're coming to some mutually beneficial exchange, and if you negotiate until you reach a Pareto optimum, you're going to reach a Pareto optimum on the contract curve, somewhere between your initial indifference curve and her initial indifference curve, right, in other words, in this space here. We're going to call this the core, because this is going to represent essentially all of the feasible outcomes that could come out of mutually beneficial exchange between the two parties, right, that doesn't leave anything on the table. Okay, awesome. So in the next video, we're going to talk about how to solve problems and calculate the contract curve, the negotiation space, and the core.